Section 3.1, Introduction to Graphing. So we're going to start off this section with some definitions and some basic ideas that we're going to be able to use whenever we need to graph in what is called the rectangular or Cartesian coordinate system. Alright, so the first thing that we will identify is that the x-axis is the horizontal axis. So remember, horizontal runs left and right. So this is the x-axis and it runs left and right. The y-axis is the vertical axis, and vertical we think of as up and down. So there's the y-axis. Alright, so what is the origin? Alright, so the origin is the point where these axes intersect. So this point is called the origin. So now, what we take of that is the origin, we think of that as sort of the 0 point. Now, if we move to the right of the origin, if we move to the right, we say that the x values are becoming larger. Okay, so the x values are becoming more positive. So if we move to the right of the origin, x is positive. If we move to the left of the origin, x is negative. Alright, so moving left and moving right, those are changes in x. As we move to the right, x becomes more positive. As we move to the left, x becomes more negative. If we move above the origin, the y value changes. And we say above the origin, y is positive. And if we are below the origin, y is negative. Alright, so as we move further up, the y value increases, becomes more positive, and as we move down, the y value decreases, becomes more negative. We also have what are called quadrants. So basically, we have these axes, the horizontal and vertical axis, they cut up the plane into 4 pieces called quadrants. And we call the upper right quadrant 1, and it's with a Roman numeral, and this would be quadrant 2, and quadrant 3, and finally quadrant 4. Alright, so we give Roman numerals for the quadrants. Alright, so that's just some basic terminology and sort of the situational understanding of the system. Alright, so now another thing that we're going to be using are these things called ordered pairs. And ordered pairs are written as x comma y. Yes, we need parentheses, and yes, a comma is required. This ordered pair indicates an x coordinate and its corresponding y coordinate. So it gives us, it tells us where in space, in the flat surface, this point lies. It tells us an x coordinate and a y coordinate so we can locate it. So for example, if we wanted to plot the point 5, 7, I'll plot this in black. If we wanted to plot the point 5, 7, this is telling us that the x-coordinate is 5 and the y-coordinate is 7. So we would move to where the x-coordinate is 5 and move to where the y-coordinate is 7, and we would sort of line those up. The x-coordinate is 5, the y-coordinate is 7. We plot the point. This is the point called 5, 7. Plot the point negative 3, 2. The point negative 3, 2 has an x-coordinate of negative 3 and a y-coordinate of 2. So first find where the x-coordinate is negative 3 And then also, where is the x-coordinate -3 and the y-coordinate +2? So move to where the x-coordinate is -3, and then to where the y-coordinate is 2, and plot that point. Alright, why don't you pause and plot the remaining 4 points on your own. Alright, plotting the point 4, -8 in green. We first find where the x-coordinate is 4, and then where the y-coordinate is -8, and basically intersect them. Here's where the x-coordinate is 4, where's the y-coordinate -8, and intersect them. This is the point 4, -8. Where is the point? -9, -6. Where is the x-coordinate -9? Right here. Where is the y-coordinate -6? Right here. Where do they intersect? This point is -9, -6. Alright, -5, 0. Where is the x-coordinate -5? Right here. And the y-coordinate 0. Well, that means you are not above the origin. So you're level with the origin, but just to the left of it. So -5, 0 is here. And finally, 0, 4 says you are not to the left or the right of the origin. You are level with the origin as far as left-right is concerned. You are just 4 points above it, or 4 marks above it, I should say. So that's some basic, how do you plot points? And you should, maybe practice this. So let's kind of go back for a moment to the quadrants. So recall, I labeled these, and I'll just use capital Q. I labeled them as quadrant 1, 2, 3, and 4. So now, to get to any point in the first quadrant, I would have to have a positive x value and a positive y value. So any point in the first quadrant would have the characteristic, what would it look like? It would look like positive, positive. Similarly, any point in the second quadrant, to get to any point in the second quadrant, the x-coordinate would be negative, the y-coordinate would be positive, would be negative, positive. The third quadrant, the x-coordinate would be negative, and the y-coordinate would be negative. And finally, the fourth quadrant, the x would be positive, and the y would be negative. And that takes care of, a lot of the points on the plane, but not all of them. Let's say, for example, we considered a point over here somewhere that was on the x-axis to the right of the origin. Well, this point has a positive x-coordinate, and its y-coordinate is 0. And if we looked at a point up here somewhere, its x-coordinate is 0 and its y-coordinate is positive. A point over here left of the origin would look like negative, 0, and finally a point directly below the origin would look like 0, negative. And that takes care of all of the points but one. That point smack dab in the middle, the origin has the ordered pair 0, 0. Alright, so now let's kind of take this in the other direction. Here I've put some coordinates. I've plotted points on the system, on the Cartesian coordinate system. And so now let's go in the other direction. Let's take these points and identify the coordinates. Alright, so for example, the point A has an x-coordinate of -5 and a y-coordinate of 3. A could be identified by the ordered pair -5, 3 in parentheses. Alright, so now take a moment, pause the video, and identify the remaining 5 coordinates for their respective ordered pairs. The point labeled B has an x-coordinate of -3, and since it's directly to the left of the origin, its y-coordinate is 0. So the ordered pair B would be identified by the point, or the coordinates -3, 0. The point C is 2 units left of the origin and 8 units below the origin. So its ordered pair would be -2, -8. D is simply 6 units above the origin. Its ordered pair would be 0, 6. E is 6 units right of the origin and 3 units below the origin, 6, -3. And finally, point F is 7 units right of the origin and 2 above the origin, 7, 2. So now let's say we wanted to plot these points: 10, 30, -20, 10, 40, 0, -30, -10, and 0, -20. Now, to plot the point 10, 30, I need to move 10 units right of the origin and 30 units above the origin. Well, that's going to take a lot of marks. However, what if instead I said, instead of each mark meaning 1 unit, how about I said, well, let's say that each mark means 5. So 5, 10, 15, and similarly on the y's, 5, 10, 15, and on the x, -5, -10, -15, and again on the y, -5, -10, -15. Then the point 10, 30 would be 2 marks right and 6 marks up. So what I'm using here is I've adjusted the scale. So be careful with scale. Remember that if the first mark means 5 units, each mark means 5 units. If the first mark means 1 unit, each mark means 1 unit. You must be consistent on each axis. Alright, so plot the remaining 4 points. -20, 10 would be 4 marks left, 2 marks up. 40, 0 would be 8 marks right, no marks up or down. -30, -10 would be 6 marks left, 2 marks down. And finally, 0, -20 would be 4 marks directly below the origin.